Good morning, my dear children. Today we are going to learn about hydrogen and its compounds. It's a very important chapter, a very easy chapter. So without any delay, let us go into the topic. This chapter I am going to deal with certain objective questions whichever you will be coming across in this lesson, because this is totally comes under inorganic chemistry, and it consists of lot many preparations. Okay, you all have already aware of hydrogen and its compounds. Okay, a little introduction I will be giving for you, and later we will be dealing with objective questions whichever we come across in this lesson. Okay, so hydrogen and its compounds, this is our topic for today. Hydrogen and its compounds. Okay, hydrogen and its compounds. Okay, so you all are aware that hydrogen atomic number is 1, atomic mass is also 1. Okay, Z is equal to 1, and mass number A is also equal to 1. Okay, and compounds of hydrogen, what are the different compounds exhibited by or compounds formed by hydrogen? Okay, what are the different compounds formed from hydrogen? Yes, you have several compounds, like first one is water, H2O. Okay, it is one of the very important compound which is formed by what? Hydrogen. And then ammonia, you all know. Ammonia is one of the important compounds of hydrogen. Hydride of nitrogen, you call it as ammonia. Okay, and hydrogen peroxide. In this lesson we are going to deal with these compounds, okay, and their preparations and properties. Hydrogen peroxide, H2O2. Okay, and you have heavy water which is called as D2O. Okay, so about this type of compounds, and halides of hydrogen also we have, that is hydrogen halide. Okay, hydrogen halides like what? HCl, H2SO4, like that. Okay, sorry, HCl, HF. Okay, hydrogen halides. Fifth type of compounds are what? Hydrogen halides. Okay, so about all these compounds, it has been discussed in this lesson. Right, hydrogen halides like what? HCl, HF, HBr, all these comes under hydrogen halides. Okay, so it has been discussed about all these topics in this lesson. Okay, so before you go for the different compounds that are being exhibited by hydrogen, we should know what are the isotopes of hydrogen. Just recall the isotopes. What are isotopes? Isotopes are the substances which are having same atomic number but different mass number. Okay, now same atomic number but different mass number. You call them as what? Isotopes. Okay, same atomic number but different mass numbers. Such kind of substances are called as what? Isotopes. Okay, different mass numbers. Okay, generally we represent any element in terms of its atomic number and its mass number. The representation we will give it like this. Suppose if X is one element, its atomic number we will write it down. Okay, atomic number generally represented by letter Z, and mass number you will write it on the top. So for hydrogen, if you speak about, hydrogen symbol is H, its atomic number is 1, its mass number is also 1. So this is normal form of hydrogen. This hydrogen exists in the form of isotopes also. Okay, same hydrogen but with different mass numbers. Atomic number will be same but different mass numbers. Like that also certain isotopes are existing for hydrogen. So what are the isotopes of hydrogen? 1H2 and 1H3. Okay, you are finding three elements with same atomic number 1 but different mass numbers 1, 2 and 3 respectively. Here 1H1 is considered to be what? Hydrogen, or in other words you call it as what? Protium. Okay, and 1H2 is called as what? Deuterium. And 1H3 is called as what? Tritium. So these three are considered to be what? Isotopes of hydrogen. Okay, protium 1H1, deuterium 1H2, tritium 1H3. These three are considered to be the isotopes of hydrogen. Okay, now in these three isotopes, tritium is considered to be radioactive isotope of hydrogen. Okay, now tritium is considered to be what? Radioactive isotope of hydrogen. And deuterium almost exhibits the properties as that of normal hydrogen only. Okay, and it exhibits the chemical properties also similar to that of normal hydrogen only. Okay, so like that 1H1 represents what? Protium. And if you wanted to find out the isotope which does not have neutrons, okay, now most of the times they will be asking questions like which of the following isotopes of hydrogen does not have neutrons, like that also they will ask. So to calculate the number of neutrons, you have the formula A minus Z, number of neutrons you can calculate. Okay, for protium, what are the number of neutrons? Okay, A minus Z. Here 1 minus 1 for protium means for normal hydrogen 1 minus 1. That means there are no neutrons. Neutrons are not there in protium, or in hydrogen you will not find neutrons at all. Okay, so this question so many times it has been asked, so you have to focus on this point, right? And if you comes to deuterium, number of neutrons are how many? 2 minus 1, which is equal to 1. Means in deuterium you will find 1 neutron, and in tritium you will find 3 minus 1, which is equal to 2 neutrons. So the isotope of hydrogen which does not have neutrons at all is what? Yes, it is protium. Protium is nothing but what? Protium means nothing but hydrogen only, normal hydrogen. Okay, so now we will come across different properties exhibited by hydrogen. What are the different properties exhibited by hydrogen? You all know that if you go for the physical properties, hydrogen is a colorless, odorless and tasteless gas. Okay, now hydrogen does not have any odor, does not have any color, and it's a tasteless gas. Okay, exists in the form of what? Gas. It is lighter gas, the lightest gas we can say, because atomic number is 1 only, and it is considered to be the most lightest gas, isn't it or not? Yes, and it is insoluble in water. It reacts with other substances, and suppose if it reacts with oxygen, atmospheric oxygen, it forms water. It reacts with atmospheric nitrogen, it forms ammonia. Okay, like that it forms several hydrides as well as oxides also when it reacts with the suitable substances. Okay, so like that it exhibits certain important properties. Okay, general properties. Okay, and then it even reacts with acids. Okay, hydrogen, whenever acids react with metals, you can get hydrogen gas. Like that you have learned certain points in your lower classes. Okay, and in this chapter you will be coming across, if you go for the compounds of hydrogen, you will be coming across water, the main compounds of hydrogen. In compounds of hydrogen, the main compound which you will come across is what? Water, H2O. Okay, H2O, water. Okay, the most abundantly used substance. Okay, universal solvent is what? Water. Okay, so water is the compound formed by hydrogen. Okay, how does water is formed? Water is formed by the treatment of H2 and O2 in presence of electricity. By sending electric spark, you can get water from hydrogen, isn't it or not? You can get water from hydrogen by sending electric spark. Okay, so water, generally water is having what? Bond angle 104, and bond angle is 104 degrees, and then bond length in between H and O. You will have the structure like this for water. Okay, with 2 lone pairs of electrons will be there with bond length 104 degrees. Okay, now bond length 104 degrees, right? And bond angle 104 degrees, and bond length is how much? Bond length is almost around 95.7 picometers. Okay, 95.7 picometers. Sometimes they will ask this kind of questions also. So you have to focus on that kind of questions also. Okay, and the crystalline form of water is what? Ice. Ice is a crystalline form of water, and ice floats on water because of its less density. And ice floats on water because ice will have open cage structure because of the presence of what? Hydrogen bonding. Okay, so like this certain points you will be learning in the topic of water. Okay, and then if you go for the next compound, it is ammonia. But before we go to the next compound, you have to learn some important points regarding water. Here you will be coming across a kind of water which is called as what? Hard water. Okay, what is hard water? Hard water is the type of water which does not give lather with soap. Lather means what? Foam. Foam will not come. Okay, that kind of water is called as what? Hard water. Okay, hard water can be either it can be a pond water or well water, or it can be a river water also. If it does not give lather with the soap, you call it as what? Hard water. Okay, hard water. So why hardness occurs? Why water is said to be hard? Okay, because of the presence of what substances? Why water is said to be hard water? Okay, hardness of water is due to the presence of what? Yes, certain carbonates and bicarbonates of calcium and magnesium which are there inside it. Okay, and some of the hard water consist of chlorides and sulfates of calcium and magnesium inside it. If these salts are present, okay, either in trace quantities or in large quantities, okay, the water is said to be what? Hard water. Okay, hard water is not at all suitable for drinking and even for domestic purpose also. You cannot wash your clothes, utensils, whatever it may be. It will not give lather with soap. Lather means what? Foam. Foam will not come. Okay, so it is not suitable for domestic purposes. Now to remove this hardness of water, okay, actually permanent hardness will be there, temporary hardness will be there. Hard water, okay, hardness can be 2 types, temporary hardness, permanent hardness. Okay, now temporary hardness and permanent hardness will be there. Okay, so permanent hardness and temporary hardness, how they are classified means, if water contains carbonates and bicarbonates of calcium and magnesium, then you can remove that hardness either by boiling or by just adding lime, slaked lime, calcium hydroxide. If you add, the hardness of the water can be removed. Okay, listen here. Temporary hardness is due to the presence of what? Due to carbonates and bicarbonates of calcium and magnesium. Okay, now calcium carbonates and bicarbonates of what? Calcium and magnesium. If they are present in water, water will get what? Temporary hardness will come. Okay, permanent hardness is due to the presence of what? Due to the presence of chlorides and sulfates. Chlorides and sulfates of calcium and magnesium. If they are present, then it gives permanent hardness for water. Okay, so temporary and permanent hardness. So temporary hardness can be removed by what? By boiling or by adding lime. Okay, now can be removed by boiling. Can be removed by boiling or by adding lime. What is lime? Slaked lime. calcium hydroxide is called as what? Slaked lime. By boiling or by adding lime. Okay, now by adding lime. Here lime means what? Calcium hydroxide. Okay, I'll just write this side. So by adding lime, you can remove that temporary hardness of water. Okay, lime is what? Calcium hydroxide. If you add this calcium hydroxide, the hardness of the water can be removed. Okay, and this process, adding of lime to remove the temporary hardness, you call this process as what? Clark's process. Okay, adding of lime to remove the hardness. To remove the hardness, you call it as what? You call it as Clark's process. Okay, so Clark's process is the process which is to be applied to remove the temporary hardness which is there in water. Okay, similarly, if you go for permanent hardness, okay, permanent hardness is due to the presence of what I said? Chlorides and sulfates of calcium and magnesium which is there in it. Okay, so permanent hardness you can remove. Permanent hardness can be removed by what? Permanent hardness can be removed by adding what substance? Calgon substance. What is calgon? Sodium hexametaphosphate. Sodium hexametaphosphate. Na6P6. Sodium hexametaphosphate is called as calgon. Na6P6O18. Okay, now Na6 calgon method. Please remember calgon. This calgon is a chemical substance. Sodium hexametaphosphate. Okay, now sodium hexametaphosphate is called as what? Calgon. Okay, so Na6P6O18 is called as what? Sodium hexametaphosphate, and this substance you call it as what? Calgon, and that's why this process of removing permanent hardness is called as what? Calgon method. And there are other methods are also there which are called as what? Which comes under the removal of permanent hardness. There are other methods are also there. They are ion exchange method. Okay, resins method. Okay, now resins. By adding resins, in that method also you can remove permanent hardness of water. Okay, so in that mainly most of the times they ask will be about calgon method. Calgon is nothing but sodium hexametaphosphate. By adding that, the hardness, the permanent hardness of the water can be removed. Okay, even by adding carbonates and bicarbonates of sodium and magnesium. Okay, sodium carbonate or sodium bicarbonate if you add also, they can be used for removing permanent hardness of water. Okay, so that is also one very important point which you have to remember. Right, now coming to the next compound of hydrogen, that is H2O2. H2O2, it is one of the peroxide form of hydrogen. H2O2. Okay, now second compound is what? H2O2, hydrogen peroxide. Okay, now H2O2. You all are aware that in peroxides the oxidation number of oxygen is how much? Yes, -1. Okay, sometimes they'll ask this kind of questions also. H2O2 means what? Hydrogen peroxide. Hydrogen peroxide. Okay, H2O2 means what? Hydrogen peroxide. So in this, this is mostly used as what? It can be used either as an oxidizing or as a reducing agent also. Okay, it can be used in both the ways. It can be used as either oxidizing agent or reducing agent. In either way you can use it. Okay, and one more important thing is it can be used as a disinfectant to remove suspended particulate matters which are there, suspended pollutant contents or pollutant effluents whichever are there in the atmosphere. To remove them you can use this hydrogen peroxide. Okay, so hydrogen peroxide is one of the very important what we call compounds of what? Hydrogen. Okay, so if you go for the uses, as just already I told you, okay, uses are what? It acts as a very good reducing agent or bleaching agent. Okay, good bleaching agent. Okay, bleaching agent means what? It bleaches away the unwanted waste materials whichever are there, gets bleached away, go away. Good bleaching agent. Okay, as a disinfectant also, we can use this as a disinfectant substance. Okay, and it acts as an oxidizing as well as reducing agent. Okay, it is used in the synthesis of tartaric acid. I think you are aware of this tartaric acid. Used in the synthesis of what? Tartaric acid. Used in the synthesis of tartaric acid. Okay, so like that certain uses are there, and also to remove the suspended pollutants whichever are there in the atmosphere, to remove them, this hydrogen peroxide is used. And you all are aware that hydrogen peroxide is having what type of structure? Non-planar structure. Okay, hydrogen peroxide has what? Non-planar structure. Okay, non-planar structure, please remember. So like that you will be getting certain questions on H2O2 based on their properties and preparations. And next we go to heavy water. Okay, heavy water is what? D2O. Okay, heavy water is what? D2O. Okay, D is what? Deuterium. Heavy water is called as what? Deuterium oxide. Okay, it exhibits same properties as that of normal hydrogen only. Okay, and preparation methods and properties are also same as that of normal hydrogen only, but it is heavier than normal hydrogen because of the presence of neutrons. Neutrons are available in deuterium. Okay, so it is a little bit heavier. D2O is largely used in what? Nuclear reactors. Okay, mostly used in what? Used in nuclear reactors. Okay, now it is used in what? Nuclear reactors. So heavy water, D2O. Okay, so like that you have certain topics have been covered in this lesson. Now we will directly go for certain objective questions which you will be coming across in your examination. Like in previous exam, what type of questions you got? Okay, let us go for the objective questions which you will be coming across in this lesson. Okay, previous EAMCET questions. Previous EAMCET questions. Okay, so once look at this way of questioning. I would like all of you to please note down, write and practice. Okay, yes. So once look at this, it was given like a match the following here. Okay, list 1, list 2, like that it is given, and it is given like a match the following. Okay, so in that A, B, C, D, 4 questions are given. A, B, C, D. In that H3BO3, AlCl3, H3BO3, AlCl3. Okay, B3N3H6, B3N3H6, and last one is given as BF3. Okay, and that side options are given like list 2, physical and chemical property or name of the structure, anything they were given, just try to match them. Okay, dimeric form, first option or number 1 is what? Dimeric form, and number 2 is back bonding. Number 3 is hydrogen bonding. hydrogen bonding, and number 4 is inorganic benzene. Inorganic benzene. So you have to match these 4 with the 4 questions which are given in list 1. Okay, so H3BO3 means what? What type of bonding will be there? H3BO3 means what? Boric acid. H3BO3 means boric acid. In boric acid, you will be finding what? Hydrogen bonding you can find. AlCl3 can exist as Al2Cl6. Okay, so it can exist in the form of a dimer. Dimer means, I think you have idea. If two substances combine with each other to form a big molecule, then it will be existing in the form of dimer. Single substance is called as what? Monomer. Whereas if two substances, if they are joined, you call it as what? Dimer. Okay, so AlCl3 exists as dimer. Here H3BO3 will have hydrogen bonding, and B3N3H6 means it has same structure as that of benzene. So it is called as what? Inorganic benzene. B3N3H6 means what? Borazole. Please remember, B3N3H6 means what? Borazole. Okay, so BF3, what is left for BF3? BF3 will have back bonding. Okay, now BF3 will have back bonding. So options are what? A3, B1, C4, D2. Okay, so these are the options which you will get for this match the following. Yes, next we will go for the second question, which is also considered as match the following only. Okay, please look at this. This is also your previous EAMCET question. Okay, once look at this question, match the following only. SO2, CaC2, Al4, C3. List 1. List 1. And here it is given as list 2. Okay. So in that 1, 2, 3. 3 questions are given like what? SO3, CaC2, Al4, C3. SO3, CaC2. Calcium carbide this is. Al4, C3. This is aluminum carbide. Okay, that was given in list 1. And in list 2, okay, C2D2, CD4, D2SO3. See here, I think this side he gave it like ABC. Instead of 1, 2, 3, he gave it like what? ABC. And this side 1, okay, so 5 also there, D2SO4, C2D2, CD4, C2D2, CD4. Okay, what is that C2D2? It is same like C2H2. C2H2 means acetylene. Now C2D2 means what? Deuteroacetylene. D2SO3, C2D4, D2SO3, C2D4, and fifth one is also there. What is that? Fifth one, D2SO4. Okay, see, instead of H you are finding D there. Okay, if it is C2H2 you call it as what? Acetylene or ethine. Okay, now here instead of hydrogen you are finding D here. That means it is deuterohydrogen. Okay, deuterohydrogen or deuteroacetylene. C2H2, the whole word, whole compound is what? Deuteroacetylene. Okay, same like that deuteromethane, and same like that deuterosulfurous acid, deuteroethene, deuterosulfuric acid. Okay, now your question is what? You have to match them. Okay, SO3 when added with heavy water, it is given like that. On the top of this gives rise to arrow. Okay, heavy water is written here. Heavy water. That means SO3 on treatment with heavy water, what you are going to get? Generally SO3. On treatment with normal water, you will be getting what? H2SO4. Here, instead of normal water, you took what? Heavy water. That means it is deuterosulfuric acid you should get. So first one, by treating SO3 with heavy water, what you will get? Deuterosulfuric acid. So for option A, for question A, option is 5. 5 is the correct answer. Next, you have learnt that in the preparation of acetylene, CaC2, calcium carbide reacts with water to give acetylene gas. Okay now, calcium carbide when reacts with water, it gives acetylene gas. Okay, here also, calcium carbide reacts with excess H2O, excess D2O, like that it is given. Then it gives what? Acetylene gas. So for option B, 1 is the correct answer. Okay now, calcium carbide when reacts with water, it gives acetylene gas. But here instead of normal water, what you are taking? Heavy water you are taking. So here deuteroacetylene you will get. C2D2 means what? Deuteroacetylene. Please remember. Same like that, Al4C3 when reacts with excess D2O, you will get methane. Okay, instead of methane, here instead of hydrogen, here deuterium is there. So it is called as what? Deuteromethane. Okay, so C2 will be the correct answer. Okay, very important, match the following this is. So please go through. And next let us go with the third question. Question number 3 is what? The correct order of reducing ability of the following hydrides, it seems. Reducing ability. Correct order. Reducing ability. Correct order. For reducing ability, correct order is what? Okay. So here options, you have to write the decreasing order of reducing ability. Okay. So BiH3. Okay. I'll just give you the comparison later. BiSB, BiH3, SbH3, PH3, NH3. Okay. Reducing ability. Okay. Reducing ability will be more for BiH3, bismuth hydride, antimony hydride. PH3 means what? Phosphine. And NH3 is ammonia. Okay. So here what they asked? Reducing ability they asked. Okay. Now reducing character of hydrogen will be more in what? BiH3. It will be less in ammonia. Okay. So he asked about that order. So among 4 options, this is the correct answer. I am not writing the 4 options, you only please check. So we'll go to the 4th question. Hydrogen peroxide is stored away from light because it gets decomposed when exposed to light as, okay, H2O2 always to be stored where? To be stored away from light. Always stored away from light. Why away from light? Why we will store H2O2 away from light? Because correct answer is what? It decomposes into what? H2O and oxygen, O2. It decomposes into what? H2O and O2. He gave 4 options like it decomposes into dash. Option A H2O and O2, option B H2 and O2, option C H2O and H2, option D H2O and O2. Generally hydrogen peroxide decomposes into what? Water and oxygen. I am writing only the correct answer option. 4 options I am not writing in order to save time. Okay, so please check. This is only the answer. And next, question number 5. Okay, so here also you have to do the match the following only. Match the following questions, theoretical questions. I mean conceptual questions you will be getting. Okay, look at this. Question number 5. Again you have match the following. Okay now. So match the following. How? What is given in column 1? Column 1, column 2. Okay, column 1, column 2. So in that what they gave? Treatment with washing soda. Okay, treatment with washing soda. Treatment with washing soda. Okay, option 2 what they gave? Treatment with washing soda and Calgon's method, Clark's method. Calgon's method, Clark's method, Calgon's method and Clark's method, and permutate process. Permutate process. Okay, permutate process. Okay, in this, what are the options which are given for the other one, other side? CaOH taken twice. CaOH taken twice. Na2CO3. Okay, treatment with washing soda. Washing soda itself is Na2CO3. And next, sodium aluminum silicate. Okay, Na2 NaAlSiO4, that is given. Sodium aluminum silicate, NaAlSiO4. And option D what is given? Na6P6O18, that is only Calgon. Na6P6O18. Okay, so you have to do match the following here. So treatment with washing soda means just you have to go with the formula. Then Calgon's method. What is Calgon's method? You have to use sodium hexametaphosphate. Okay, so in that the option will be D. Then Clark's process is what? Adding lime is called as Clark's process. Okay, so you will have to match like this. And permutate process, and even this can even be given as zeolite process. Okay, zeolite, sodium aluminum silicate, you call it as what? Zeolite. Okay, to remove hardness of water you will use even sodium aluminum silicate. Okay, so like this you have to do match the following. So what is the option? For A 2, for B 4, for C 1, for D 3. Okay, for A, okay, here this side A B C D they give. If you take this side A B C D, okay, whatever it may be, I'll just do like this. 1 for 1 B, for 2 D, for 3 A, and for 4 C. So this will be the way of questioning you will get. Okay. Yes. Next, go for the next question. Hard water contains ions of dash and dash. Sixth question. Hard water. Just now we have discussed. Hard water contains ions of calcium and magnesium. When water is said to be hard water, okay, if it contains ions of calcium and magnesium, okay, hard water, when you call water is said to be hard, okay, if it contains chlorides and sulfates of calcium and magnesium present in it. So hard water contains ions of dash and dash, means what you will write, calcium and magnesium. I am not giving the options here, it takes little time. Okay, and next, okay, with reference to the redox properties of hydrogen peroxide, which of the reactions are feasible? Feasible reactions, redox reactions, if you go for, okay, hydrogen peroxide can act as what? As well, it can act as reducing as well as oxidizing agent. Okay, so if any equations are given to you, hydrogen peroxide acts in what way? Okay, like one example I will give. I will not give all the 4 reactions. You just check this equation. One equation is given like this. Equation is given like this. Okay, what is that equation? Fe2 plus 2Fe2 plus 2Fe2 plus 2H plus H2O2. Okay, H2O2 gives rise to what? 2Fe3 plus 2H2O. 2Fe3 plus 2H2O. Like this, one equation is given. In this, H2O2 acts as what reagent? What agent? Is it acting as reducing agent or is it acting as oxidizing agent? You have to check with that. Okay, so here hydrogen peroxide means oxygen's oxidation number is always -1, hydrogen's oxidation number is +1. But here hydrogen peroxide converted into what? Water. So oxygen's oxidation number is -2, hydrogen's is as usual +1 only. That means -1 to -2. It became -1 to -2, means it is reduced. So here hydrogen peroxide undergone reduction. If it is undergone reduction, then it is which agent? It is oxidizing agent. Please remember. Okay, now hydrogen peroxide here in this equation, it is acting as what? Oxidizing agent. Okay, now you are asked about that only. Okay, they will be giving options like it acts as oxidizing agent, it undergoes reduction, both A and B, none of the above. Like that, if they give options, you have to check with the options by checking with what? Oxidation numbers. Okay, so you please go through such kind of equations where hydrogen peroxide either acts as oxidizing agent or it acts as reducing agent. Okay, check with the given equations. Okay, and next we will go for the next question. Okay, so you have to focus on what kind of questions? Questions which are based on hydrogen peroxide, questions which are based on hard water and deuterium, heavy water. Okay, if you focus on these 3 activities, if you focus on these 3 areas, it will be enough for you. Okay, and next, once you look at this question, decreasing order of ionizable hydrogen atoms. This is also a very important question. Just you look at this. Decreasing order of ionizable hydrogens, it seems. Decreasing order of ionizable hydrogens. Ionizable hydrogens. Decreasing order of ionizable hydrogens. Okay, so what is decreasing order means? What question, what compounds are given? Once check. H3PO4 is there. Okay, H3PO4. In that, how many hydrogen ions are ionizable? That you have to identify. And then H3PO3 is given. H3PO3, H3PO2 and H4P2O6. H3PO2 and the other compound. Let me show you the number of what we call ionizable hydrogens. Okay, see, look at this structure H3PO4. Okay, if you just look at this structure, you will have 3 OH minus ions will be there. See here, P double bond O. Okay, OH, here one OH and here one OH. Okay, so here all the 3 hydrogen atoms are not directly connected to phosphorus, so all the 3 can be ionizable. Okay, now they are connected to what? Oxygen. They are not directly connected to the central atom. The hydrogen atoms which are directly connected to the central atom only can be ionizable. Please remember that point. Okay, now the hydrogen atoms which are directly connected to the central atom, if you go for the structure, the hydrogen atoms which are directly connected to the central atom only can be ionizable. So all the 3 hydrogens are connected to oxygens, but they are not connected to phosphorus here. So that's why all the 3 can be ionizable. Okay, if you go for H3PO3, what will be the structure? Here once look at this H3PO3 structure, P double bond O. Here one H is directly connected to the central atom phosphorus. Okay, and the remaining 2 hydrogens, they are connected with the oxygens. So here ionizable hydrogens are 3. Ionizable hydrogens he is asking for. Ionizable hydrogens how many? 3. And here ionizable hydrogens are only 2 only. Ionizable hydrogens. Okay, now ionizable hydrogens here only 2 are there. Okay, because here one H is directly connected to the central atom. It cannot be ionizable. Please check with that. So you have to go with the structures. Then only you will be getting idea about ionizable hydrogens. Okay, so go for the third structure. Okay, what is the third structure which is given to you? H3PO2. There I have written H3PO2. What is H3PO2? See, it is having the structure like this. P double bond O. 2 hydrogens are connected directly to the central atom phosphorus, and 1 hydrogen is connected to oxygen. So only this 1 hydrogen is replaceable. So ionizable hydrogens are only 1. Okay, now ionizable H's only 1. And finally they gave one more question, H4P2O6. H4P2O6. Okay, now that means it is like H2PO3 only. Okay, it is like H2PO3 only. It's not given previously. Okay, once look at this. P single bond P, here double bond O, OH. Here also one OH, here also one OH, and all 4 sides OH will be there. So here all 4 hydrogens are connected to oxygens only. None of the hydrogens are connected to phosphorus. So all 4 hydrogens can be replaceable. So number of ionizable hydrogens here, how many are there? Ionizable hydrogens, it is equal to 4 hydrogens. Ionizable hydrogens, you have 4 are there. So he is asking for what? Decreasing order. Okay, so decreasing order means less number of ionizable hydrogens will be for this structure. Okay, decreasing order, more will be for this structure. So if you keep them as 1, 2, this is 3, this is 4, if they take, order will come as what? 4, structure 3 will have more number of ionizable hydrogens. So structure 3 greater than, structure 1 greater than, 2 greater than 4. Okay, like this will be the order, decreasing order. Okay, decreasing order, more number of ionizable hydrogens, that you have to write first. This structure has 4 ionizable hydrogens. Okay, whereas this structure has only 1 ionizable hydrogen. So you were asked about this question. Order you have to check and you have to keep the correct answer. Okay, So this is a very important question which you will be coming across. Okay, and next we'll go for the 9th question. Okay, look at this 9th question. Okay, and next what will be the organic compound formed? 9th question. Same like normal hydrogen only. Deuterium oxide also exhibits same properties as that of normal water. Deuterium oxide is what? D2O. Please remember, heavy water exhibits same properties, chemical properties also same properties as that of water. See what will happen? What will happen if what will be the organic compound formed? Not what will happen. What will be the organic compound formed? Okay, now what will be the organic compound formed? Organic compound formed when aluminum carbide reacts with deuterated water. Formed when aluminum carbide, it seems, Al4C3. Aluminum carbide means what? Al4C3 react with heavy water. Okay, react with heavy water. What organic compound will form? Normally if it reacts with normal water, aluminum carbide reacts with normal water, you will get methane. Here you will get deuteromethane. Okay, CD4. Answer is what? CD4. Instead of CH4, you will get here CD4. Okay, now deuteromethane is the answer. Okay, this even I gave this in match the following also. Okay, look at this. Right, even when calcium carbide reacts with water, it forms. If they give, instead of aluminum carbide, if they give calcium carbide, you will get what? Deuteroacetylene. Okay, look at, remember that point. And here one more question is given like this. Once check. Okay, how many emission spectral lines are possible? This is also very important. How many emission spectral lines? How many emission spectral lines are possible? Okay, now spectral lines formula is there for us. Spectral lines are possible. Okay, how many emission spectral lines are possible when hydrogen atom is excited to nth energy level? For spectral lines, n into n minus 1 by 2 is the formula. Okay, you have the formula of spectral lines. When hydrogen is getting excited from nth energy level, it is given. Directly is asking for the formula only. Okay, when hydrogen is emitting from nth energy level, that is the question. When hydrogen is excited to, when hydrogen is excited to nth energy level. Okay, now excited to nth energy level. This is the question. Okay, answer is what? How many spectral lines will form? The number of spectral lines that can be formed whenever an electron jumps from any of the higher energy level to lower energy level. For that, the formula is what? N into n minus 1 by 2 is the formula, where n is the nth energy level. If that n value, if they give, you can substitute that n value and you can find the number of spectral lines. So accordingly, you will get one value. You have to check that value. Okay, so like this, you will be getting certain important questions. I dealt with this chapter is not a big chapter. I dealt with some important questions from this topic. I tried my best. Okay, I always say to you, you please go through your textbook, go through all the concepts, revise them carefully. Okay, I always say your hard work is your superpower. Thanks for watching. Bye.